ITNT201 Routing and Switching Essentials Module 6. In this module, we are going to discuss about Ether channel. To make you understand about Ether channel, I will start my discussion with a network scenario. Assume that you are a network administrator in an organization. Your network includes redundant switches and links. You have some version of STP configured to prevent layer 2 loops. So this is your network scenario, meaning that your network is working fine, everything is properly working. But your organization asked you to improve the network performance. Assume that there are some delay in the network. Your management asked you to increase the network performance. How do you improve the network performance? What is the solution you will suggest? Okay, one of the solution to improve the network performance is to increase the network bandwidth. How do you increase the network bandwidth? The network bandwidth can be increased by creating the redundant links between the layer 2 devices. So redundancy will help you to increase the network bandwidth if you think logically. Correct. Logically it is correct. But there is a problem. What is the problem? The problem is, if you create the redundant link, it will create the layer 2 loop or redundant loop, which will affect the network communication. The STP, spanning tree protocol, will block one of the link. It will not block all the link. It will allow one link to communicate and it will block the remaining link. Then how to increase the network bandwidth? With the help of the Ether channel, we can increase the network bandwidth without the redundant loop issue. Ether channel aggregates redundant links between devices into a bundle, or it will bundle this redundant links as a single channel. So the bundle includes multiple redundant links, but it is logically considered as a single link. Now with Ether channel, your network can have redundancy, loop prevention and increased bandwidth. There are two Ether channel protocols available, PAGP and LACP. In this module, we will explain about these two protocols, and also we will discuss about how to configure, verify and troubleshoot these protocols. I hope you understand the brief introduction about this module. The objective of this module is to discuss about the Ether channel operation, how to configure Ether channel and how to verify and troubleshoot Ether channel. What we are going to discuss in this topic? In this topic, we are going to discuss about Ether channel operation. Generally, in computer networks, to increase the bandwidth, multiple links or redundant links could be connected between the devices. We know the drawback of redundancy. It will create layer 2 redundant loops, which affects the network communication. However, the STP will block redundant links to prevent the switching loop. We enable the redundancy to increase the bandwidth, but the STP block the redundant link to provide the switching loop. Then there is no use of redundancy. Then we cannot increase the network bandwidth with the help of redundancy. To overcome this problem, we have to use the Ether channel. Ether channel is the solution to this problem. Ether channel is a link aggregation technology that allows the redundant links between devices that will not be blocked by STP. Ether channel groups multiple physical Ethernet links together into a single logical link. It provides fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. When an Ether channel is configured, the resulting virtual interface is called a port channel. Ether channel has several advantages as well as some restrictions to implementation. Ether channel can be formed through a negotiation using one of the two protocols, PAGP or LACP. These protocols allow the ports with similar characteristics to form a channel through dynamic negotiation with adjoining switches. When the Ether channel link is configured using a Cisco proprietary PAGP, the PAGP packets are sent between Ether channel capable ports to negotiate the forming of channel. The modes of PAGP are on, PAGP desirable, and PAGP auto. Like that, LACP performs a function similar to PAGP with Cisco Ether channel. Because LACP is an IEEE standard, it can be used to facilitate Ether channels in multi-vendor environments. The modes of LACP are on, LACP active, and LACP passive. I hope you understand the brief introduction about this topic. We are going to discuss about this in detail in this topic. So this is a brief introduction. Let us discuss about link aggregation. What is link aggregation? Link aggregation is the ability to create one logical link using multiple physical links between two devices. This allows load sharing among the physical links rather than having STP block one or more of the links. Ether channel is a form of link aggregation used in switched network. Look at the scenario. In this scenario, we have a layer 2 switch, that is access switch, connected with two distribution switches. The layer 2 switch receives traffic from different sources at the rate of 100 Mbps or 1000 Mbps. The layer 2 switch aggregates all the traffic and must be sent to the distribution switches. Because of the traffic aggregation, links with higher bandwidth must be available between the access and distribution switches. So, the network link between the access switch and the distribution switch requires high bandwidth or redundancy between the devices. In this scenario, the access switch and the distributed switch are connected by using a single link. As a result of that, the bandwidth is not sufficient. Due to that, the communication will be slow. Then how to increase the bandwidth? By configuring the redundant link or by connecting multiple links between the access switch and the distribution switch, we can increase the bandwidth. In this scenario, access switch and distribution switch are connected by using redundant links or multiple links. So, a simple way to increase the bandwidth is creating redundant links or multiple links between the devices and to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication. However, by default, the STP is enabled on the layer 2 switch. We know the role of the STP. The role of the STP is to block the redundant links. Because when we configure the redundant link will cause the layer 2 switching loop. So to prevent the layer 2 switching loop, the STP will block one of the redundant link to communicate. So only one link is used to communicate at a time. The other link will not be used for communication. When the primary link fails, the STP allows the other link to communicate. So how to overcome this issue? To overcome this issue, a link aggregation technology is needed. So that is the only solution. Ether channel or link aggregation technology is the solution to this issue. Link aggregation is the ability to create one logical link using multiple physical links between the devices. The link aggregation technology that groups multiple physical Ethernet links together into a single logical channel. The link aggregation technology allows redundant link between the devices also that will not be blocked by STP. Link aggregation technology is also known as Ether channel technology. What are the advantages of link aggregation? The advantages of link aggregation is used to provide a fault tolerance, load sharing, increased bandwidth, and redundancy between switches, routers, and servers. So, the use of link aggregation or Ether channel technology makes it possible to combine the number of physical links between two switches to increase the overall speed of switch-to-switch communication. So, this is the main objective of the link aggregation technology. What is Ether channel? Link aggregation technology is known as Ether channel technology. Ether channel technology was originally developed by Cisco as a LAN switch-to-switch technique. It was originally developed to group several fast Ethernet or gigabit Ethernet ports into a single logical channel. When an Ether channel is configured, the resulting virtual interface is called as port channel. The physical interfaces are bundled together into a port channel interface. So when we logically combine multiple physical channel, we will get a port channel as a result of that. Let us discuss the advantages of ether channel technology. Normally, in switch, we will configure the ports individually. But in the case of ether channel, all the configuration can be done on the ether channel interface. This ensures the configuration consistency throughout the links. Also, it will save the time. To have more bandwidth or to increase more bandwidth, in some cases we may need to upgrade the link to the faster and more expensive connection. But in the case of ether channel, it relies on the existing switch port. The third advantage is the load balancing takes place between the links that are part of the same ether channel. The fourth advantage is ether channel creates an aggregation that is seen as a single logical link. When several ether channel bundle exist between two switches, STP may block one of the bundles to prevent the switching loops. When STP blocks one of the redundant links, it blocks the entire ether channel. This blocks all the ports belonging to the ether channel link. Where there is only one ether channel link, all physical links in the ether channel are active because STP consider it as a one single or one logical link. The last advantage is ether channel provides redundancy because the overall link is seen as a one or single logical connection. Additionally, the loss of one physical link within the ether channel does not create any change in the topology. So no need to worry about that. So these are all the advantages of ether channel technology or link aggregation technology. Let us discuss the implementation restrictions on ether channel. While creating ether channel, interface types cannot be mixed. For example, we should not mix the interfaces like fast Ethernet and gigabit Ethernet within a single ether channel. An individual ether channel must be created by using the same types of interfaces. Each ether channel can consist of up to 8 Ethernet ports. How ether channel communicates? It communicates in full duplex mode. It provides full duplex bandwidth between the switches in two different rates. The ether channel which provides full duplex bandwidth up to 800 Mbps is known as fast ether channel. The ether channel which provides full duplex bandwidth up to 8 gigabits per second is known as gigabit ether channel. The Catalyst 2960 layer 2 switch supports up to 6 ether channel. In 2960 switch, maximum 6 ether channels can be created. The individual ether channel group members port configuration must be consistent or same on both the devices. Say for example, if the physical ports of one side are configured as trunks, then the physical ports of the other side must also be configured as a trunks within the same native VLAN. Assume that you are configuring the ether channel between two switches. So in one end you are configuring the physical port as a trunk. In the other end, in the another switch, also you have to configure the physical port as a trunk. In both ends, the physical port should be configured as a trunk that should be within the same native VLAN. Then only the ether channel communication will be successful. Ether channel has a logical port channel interface. A configuration applied to the port channel interface affect all the physical interfaces that are assigned to that interface. If you do a change in the logical port channel interface, that is going to affect the physical interfaces. Whatever the changes done in the logical interface will be impacted on the physical interface. How to create ether channels? To create ether channels, we have to use the auto negotiation protocols. What is auto negotiation protocol? The ether channel protocols are also known as auto negotiation protocol. We already discussed that there are two types of ether channel protocols. PAC-P and LACP. What is PAC-P? What is LACP? PAC-P refers to Port Aggregation Protocol. LACP refers to Link Aggregation Control Protocol. These two protocols are used to negotiate the switches to form an ether channel. If you want to create the ether channel between two switches, we have to use any one of these protocol, either PAC-P or LACP. These two protocols allow the ports with similar characteristics to form a channel through dynamic negotiation with the neighboring switches or adjoining switches. And importantly, it is also possible to configure a static or unconditional ether channel without these two protocols, PAC-P or LACP. Let us discuss how PAC-P operates. PAC-P is a Cisco proprietary protocol. PAC-P protocols are used in switching devices to support in the automatic creation of ether channel links. PAC-P protocols allow the switch ports with similar types or similar characteristics to form a single logical channel. PAC-P protocol creates ether channel through dynamic negotiation with the adjoining switches. When an ether channel link creation is initiated through a PAC-P protocol, then the PAC-P negotiates both the switches by using the PAGP packets. The ether channel capable ports in both the switches exchange the PAC-P packets to negotiate the forming of channel. At the end of the negotiation, the PAC-P identifies the matched Ethernet links. Then it groups the links into an ether channel. Once the ether channel is created, then it is added to the spanning tree as a single port so that the STP will not block the ether channel. When PAGP is enabled on the switch, then it manages the ether channel. The PAGP enabled switches will exchange the PAGP packets for every 30 seconds to check the configuration consistency and to manage the link additions and failures between two switches. During ether channel creation, PAC-P negotiate both switches to ensure whether all ports are of the same types of configuration or having the same characteristics. So this is the main responsibility of the PAC-P protocol during the negotiation. Importantly, in ether channel, it is mandatory that all ports have the same speed, duplex settings and VLAN information. Any port modification done after the creation of the ether channel will impact all other channel ports. We will discuss the PAC-P operation in detail. Ether channel can be formed through negotiation using one of the two protocols, PAC-P or LACP. Or I can tell like this, ether channel can be created statically or it can be created dynamically. The ether channel can be manually created or it can be dynamically created with the help of this PAC-P or LACP protocol. This PAC-P or LACP protocol allows the ports with similar characteristics or of similar types to form a channel through the dynamic negotiation with the adjoining switches. I already said that it is also possible to configure a static ether channel or unconditional ether channel without PAGP or LACP. We know what is the role of PAGP in ether channel creation. When an ether channel creation is initiated by PAGP protocol, then it verifies the configuration on the both side of the switches and it ensures the compatibility of the link so that the ether channel link will be created successfully. There are three different PAGP interface modes are available. The modes are on mode, PAGP desirable mode and PAGP auto mode. Where we have to use the on mode, where we have to use the PAGP desirable mode, where we have to use the PAGP auto mode. First we will consider the on mode. Now I am planning to configure the ether channel manually. If you want to configure the ether channel manually, then you have to configure the on mode in both the switches. In both end of the switches you have to configure the on mode because this mode forces the interface to create the ether channel without the PAGP. So what is PAGP? It is an auto negotiation protocol. It will negotiate and then it will dynamically create the ether channel. Here we don't want to automatically or dynamically create. Straight away we are creating the ether channel. This is a static ether channel or it is a manual ether channel. If you want to create a manual ether channel or an unconditional ether channel, you have to configure the on mode in both end of the switches. Interface configured in the on mode does not exchange the PAGP packets. Why? Because PAGP packets are used to negotiate both the switches. In this case, when you configure the ether channel manually, no need to negotiate. So no need to send the PAGP packets. I hope you are clear about this on mode. Now we go to the next mode. The next mode is PAGP desirable mode. This is a automatic mode or this is a negotiation mode. This PAGP mode places the interface in an active negotiating state in which the interface initiates the negotiation with other interface by sending the PAGP packet. Okay, let us assume we have switch A and we have switch B. Now we want to create the ether channel between these two switches. I configured PAGP desirable mode in the switch A. If I configure PAGP desirable mode in the switch A, then this mode places the interface in active negotiating state. Active negotiating state means this interface will send the PAGP packet to the other end of the switch. It will initiate the negotiation. It will start the ether channel connection. So when it initiates the negotiation, the PAGP packets are sent to the other end. We have another mode, PAGP auto mode. The PAGP auto mode places an interface in a passive negotiating state. In this state, the interfaces respond to the PAGP packet that it receives, but it does not initiate the PAGP negotiation. When you configure the interface of a switch as a PAGP auto, then it will not initiate the connection by sending the PAGP packets. It will be in the listening mode. It will wait. It will not negotiate. It will not initiate. It will not communicate with the other end of the switch. It will not negotiate the ether channel creation. If any other switch sends the negotiation PAGP packets, then it will respond to that packet. I hope you are clear about this three mode: on mode, PAGP desirable mode and PAGP auto mode. The mode must be compatible on each side when you configure. For example, let us consider you are configuring the on mode in both end of the switches. Assume that we have two switch A and switch B. In both switches you are configuring the mode as on mode. So what is on mode? That means you are manually creating the ether channel. So in both end, if you configure the on mode, the ether channel will be created manually. No issue at all. Now we go to the second mode, PAGP desirable mode. Now I am configuring PAGP desirable mode in both end. In switch A I am configuring PAGP desirable. In switch B also I am configuring PAGP desirable. Whether the ether channel will be created or not, that is the question. Yes, it will be created. Why? Because both modes are in the active state. Both modes will initiate the PAGP connection. It will send the PAGP packets. So it is easy for both of them. If switch A sends the PAGP packets to switch B also send the PAGP packets to switch A. So the connection will be created if both are in desirable state. We go to the third mode, PAGP auto mode. For example, we are configuring the PAGP auto mode in both end of the switch. In switch A and switch B we are configuring the PAGP auto mode. The question is whether the ether channel will be created or not. In this case, the ether channel will not be created. Why? Because in both end we configure the PAGP auto mode. The PAGP auto mode places the interface in the passive negotiating state. In passive negotiating state, the interface does not send the PAGP packets. The interface only responds to the PAGP packet that it receives. So switch A and switch B will wait for the PAGP packet. Switch A does not send any PAGP packet to switch B. Switch B also does not send any PAGP packet to switch A. So both switches does not receive any negotiation packets. So the ether channel will not be formed. Now we will discuss some cross compatibility between these modes. For example, we configured on mode in switch A, we configured PAGP desirable mode in switch B. Whether the ether channel will be created or not. No, ether channel will not be created. Why? In one switch we configured the static mode, in the other switch we configured the dynamic mode. If you configure the ether channel mode, either you have to configure the static mode in both the switch, or you have to configure the dynamic mode, negotiating mode in both the switch. If you configure a static mode and a dynamic mode in different end, ether channel will not be created. So if you configure on mode one end and the PAGP desirable mode in other end, ether channel will not be created. We go to the next mode. We are configuring PAGP desirable in one end, we are configuring PAGP auto in other end. In switch A we are configuring PAGP desirable, in switch B we are configuring PAGP auto. Whether the ether channel will be created? Yes. Why? Because switch A will negotiate, send the PAGP packets to the switch B. Switch B will receive the PAGP packets, and then because it is in passive negotiating state, once it receives the PAGP packet, then it will respond to the PAGP packets. The response will go back to the switch A, so the ether channel will be created. So when you configure PAGP desirable in one end, PAGP auto in other end, the ether channel will be created. For example, if you configure on in one end and PAGP auto in other end, what happens? Whether the PAGP whether the ether channel will be created or not, that is the question. So when we create on mode in one end and the desirable mode in other end, the ether channel will not be created. Let us look at the table. The table shows various combination of PAGP modes on switch 1 and switch 2 and the resulting channel establishment. For example, we have switch 1 and we have switch 2. We have two switches. Both switches are connected. We are going to establish the ether channel between these two switches. So we are going to use the PAGP protocol to establish the ether channel. We are going to configure the on mode in both the switches. In S1 and S2 we are going to configure the on mode. If you want to manually configure the ether channel, then you have to apply the on mode. So in switch 1 you are applying the on mode in PAGP. In switch 2 you are applying the on mode in PAGP. That means you are manually creating the ether channel. So it is an unconditional ether channel. It will not negotiate anything. It will not send the PAGP packets to negotiate and create the ether channel. It will straight away directly create the ether channel. So when we configure on mode in both switches S1 and S2, then the ether channel will be established. What type of ether channel? Static ether channel or unconditional ether channel or manual ether channel will be established. Now we go to the second combination. The second combination is we are going to apply on mode in switch 1. We are going to apply the desirable or auto mode in switch 2. So if we apply this combination, what happens? Whether the ether channel will be created successfully or not? No, the ether channel will not be created. Why? Because the on mode is a static mode and the desirable or auto mode is a dynamic mode. When you configure the static mode and dynamic mode together to create the ether channel will not be formed, because on mode means in switch 1 we configured on mode. That means it is configured as a static mode. In switch 2 we configured desirable or auto. It is a negotiation mode. It is an automatic mode. So these two modes cannot be configured together to form a ether channel. So this combination will not form a ether channel. We go to the third mode. In the third mode, we are going to configure desirable in switch 1 and desirable in switch 2. We are going to configure the same mode in switch 1 and switch 2. Which mode? Desirable mode. So if we configure the desirable mode in switch 1 and switch 2, whether the channel will be established or not? Yes, the channel will be established, because both switch 1 and switch 2 will be in the active negotiating state. Both switches will exchange the PAGP packets. Both switches will negotiate and create the ether channel. So if you use desirable mode in both switches, the ether channel will be established. Right, we go to the next combination. The next combination is desirable and auto. In switch 1 we are going to use the desirable, and switch 2 we are going to use the auto mode. Whether the ether channel will be established or not. Yes, it will be established. In switch 1 we are configuring the desirable mode. So when you configure the switch 1 in desirable mode, it is in the auto negotiation state. It is in the active auto negotiation state. That means it will initiate the connection. It will initiate sending the PAGP protocols to the other end. So the S2 is in the auto mode. That means it is in the passive auto negotiation state. If any switch sends the PAGP packets, then it will send response to that. So when switch 1 actively sends the negotiation connection request to the switch 2 is in the passive negotiation, but but it will receive this packet and it will send the response PAGP packets to the switch 1. At the end, ether channel will be created. Okay, now we go to the next mode. The next mode is auto and desirable. In switch 1 we are going to configure auto, in switch 2 we are going to configure the desirable. So in this case, switch 1 will not initiate the connection. Switch 1 will be in the passive state, but switch 2 is configured as a desirable mode. Switch 2 will be in the active negotiating state. So switch 2 will send the PAGP packets to the switch 1. When switch 1 receives this PAGP packets, it will send the response PAGP packets to the switch 2. As a result of this, the ether channel will be created. Now we will see the last mode. The last mode is combination is auto-auto. In both end of the switches, we are going to configure the auto mode. So we know that the auto mode in switch 1 we are configuring as auto mode, switch 2 we are configuring as auto mode. Auto mode is a passive negotiation state. It will not initiate the connection, or it will not send the PAGP packets to initiate the ether channel formation. So in this state, both switch will be in the passive negotiation state. So no switch will send the PAGP packets. Because of this reason, no ether channel will be established between these two switches. LACP operation. Both PAGP and LACP are the ether channel protocols. Both are used to create the ether channel. But PAGP is a Cisco proprietary protocol, works only on the Cisco devices. On the Cisco devices, both PAGP and LACP protocols are supported. Whereas the LACP is a part of IEEE specification 802.3 AD. The LACP can be used to facilitate ether channels in multi-vendor environment. LACP provides the same negotiation benefits as PAGP. LACP performs the functions similar to the PAGP with the Cisco ether channel. Protocols are similar. The only difference is PAGP will work in the Cisco devices. In Cisco devices, both PAGP and LACP will work, whereas the LACP will work in multi-vendor environment. PAGP will not work in other environments, other manufacturer devices. LACP allows several physical ports to be bundled to form a single logical channel. LACP allows a switch to negotiate an automatic bundle by sending the LACP packets to the other switch. LACP helps to create the ether channel link by detecting the configuration of each side and make sure that they are compatible so that the ether channel link can be enabled successfully. Like PAGP, there are three modes in LACP. The modes are on, LACP active and LACP passive. If you see, almost the operations of these modes are also similar. First we will discuss the on mode. This mode forces the interface to channel without the LACP. The interfaces configured in the on mode do not exchange the LACP packets. So the on mode is used to create the static LACP ether channel. That's all. LACP active. This LACP active mode places a port in the active negotiation state. In this state, the port initiates the negotiation with other port by sending the LACP packets. The third mode is LACP passive. This LACP mode, passive mode, places a port in the passive negotiating state. In this state, the port responds to the LACP packet that it receives, but it does not initiate the LACP negotiation. LACP mode setting. The table shows the various combination of LACP modes on S1 and S2 and the resulting channel establishment outcome. We have two switches, S1 and S2, and these two switches are connected. We are trying to establish the ether channel by using the LACP protocol. Normally, where we will use the LACP protocol? In the multi-vendor environment. LACP will support in Cisco device as well as the other devices, multi-vendor devices. Okay, now we have different combinations. We are going to apply the mode on. We are going to apply the mode on and active or passive. And the third combination of modes are active. Fourth combination of mode is active and passive. Fifth one is passive and active. Last one is passive. So what I mean, we have two switches, switch 1 and switch 2. We are going to configure the mode on in switch 1 as well as in switch 2. In both switches, we are going to configure the mode on. So when we configure the LACP mode as on in both the switches, the question is whether we can able to establish the ether channel or not. We know that the on mode is used to enable the static ether channel, or the on mode is used to manually establish the ether channel. So when you establish the on mode in both the switches, you can establish the ether channel, that is a static ether channel. Okay, we go to the next pair of modes. The next pair of mode is on in switch 1, active or passive in switch 2. When we configure this combination in switch 1 and switch 2, we are going to configure on in switch 1, active or passive in switch 2. The question is whether we are able to establish the ether channel or not. Ether channel cannot be established. Why? Because on is a static mode, active or passive is a dynamic mode. So if you apply the static and dynamic in S1 and S2, you cannot create the ether channel. Either you have to apply the static mode in both end, or you have to apply the dynamic mode in both end. Then only we can able to create the ether channel. Okay, we move to the third pair. The third pair is active. In switch 1, we are going to configure the LACP mode as active. In switch 2 also we are going to configure the LACP mode as active. The question is whether the ether channel can be created or not. Yes, ether channel can be created. The reason is the LACP active mode means both switches are in active negotiation mode. Both switches will send the LACP packets. What it will send? It will send the LACP packets to negotiate, and it will create the ether channel. So S1 also send the LACP packet to S2. S2 also send the LACP packet to S2. So the ether channel will be established easily. Now we go to the fourth combination. The fourth combination is in switch 1 we are going to configure active mode, and in switch 2 we are going to configure the passive mode. So tell me whether we are able to configure the ether channel or not. Yes. Why? In S1 we are configuring the LACP active mode, and in S2 we are configuring the LACP passive mode. That means S1 will automatically or actively negotiate the ether channel connection by sending the LACP packets to the S2. What S2 will do? S2 in the passive negotiation state. When any device send the LACP packets, then it will respond to that packet. So now switch 2 will respond to the switch 1 LACP packet. So the connection will be established. The ether channel will be established between S1 and S2. We will go to the next combination, passive and active. In switch 1 we are going to configure passive. In switch 2 we are going to configure active. So here one of the device, switch 2 is in active. That means switch 2 is going to send the negotiation. Switch 2 will send the LACP packets to switch 1. Switch 1, after receiving the switch 2 LACP packet, it is going to send back. So in this combination also ether channel will be created. we go to the last combination. The last combination is passive-passive. In both the switches, we are going to configure the mode passive. So that means both switches will be in the passive negotiation state. No switch will start the initiation. No switch will send the LACP packet to the other device, because both are in the passive negotiation state. So no switch will send the LACP packets. As a result of that, no ether channel will be established between switch 1 and switch 2. (6.2) Configure ether channel will be discussed in the next part of this module.